Okay, I took some time off screen to add some of the fillets that I didn't add before. Um, if you want to do the same thing and you're just following along, keep in mind you need to go back to before we did the shell and go back to the timeline because this is all time based. Or it's there. I should say there is a chronological order when you're working in the part body, so you should go back to before the shell in order to add the fillets, I should say. But now I'm just going to go back to the most recent, and we will continue with the tutorial. Right, we are adding stiffeners now, so we need to create a reference plane offset by the XY plane by 8 millimeters. I'm going to add our plane here. XY plane should be the bottom plane. I'm going to go back to our reference elements, add it there, and offset by 8 millimeters. I'm going to preview, yep, in the positive direction. Top stiffener base. Yeah, I should start naming these. I'm having a lot of planes right now. Top stiffener plane. That's not how you spell it. Create a position sketch, part origin, aligned with the x-axis. Our x-axis is pointing downward right now, but yeah, that actually matches. Yep, that matches what's on screen. Create a sketch shown below. Okay, we're creating these two stiffeners over here, and they could overlap. So I will very roughly draw them out. I sort of want to go this way though. Let's see if it goes normal there. Nope. Okay, I'm gonna go against the rules. Exit. Also, I should have been in the body anyways. Define in work object. I already had that offset plane. Right, it's the top stiffener plane. Let's go this way. 110 on the left, 180 on the other side. And it seems to be aligned with the horizontal axis with the other lines. Create a line like this. Aligned here. Yep, that looks good. 110 and 180. Okay, we could do a stiffener from the top onto the surface that we have here. Yeah, that's my sketches here. I can exit. Stiffener. Neutral fiber of 2 millimeters. Neutral fiber meaning that it will be, the thickness will be added onto both sides of the line that we drew. If I don't do that, then I could specify how much material in each direction of the line, but I won't do that. Preview, that's good. Okay, now we want to do the side stiffeners, position sketch on the YZ plane. Our YZ plane being this plane right here. I'm in the right workspace. Yep. Okay, now I want to work on, I'm gonna make it vertical that way actually. Let's see if it's, yep, that's the right orientation. I'm gonna make it normal to it. I'm going to go to view and do a cutting plane. it already selected the right thing. I'll keep it that way. Let's see. So 35 by 20. Okay, let's go normal to it. And have this be coincident over here, coincident over here. Let's do constraint, measure the vertical of 35 and then 20. There you go. Now it's ISO constrained. We can exit. So it wants us to do one stiffener first and then create a pattern of them. So we could do a stiffener. We're no longer in. Yep, our sketch was right there. Okay, we are in the right place. Create a stiffener. Profile is that sketch. And it wanted 2 millimeters. There you go. Okay. Now we want 7 stiffeners, spacing of 28 millimeters. So 3 on either side. Okay, now we want to do a rectilinear pattern on this stiffener. Object pattern, stiffener, reference element. Let's just make it a plane. I could have, yeah, I could just use one of the lines, but I don't want to use line. I'll just use the default plane. So it's a more robust way of doing it. Do 3 on this side, right? And then spacing of what's 28 millimeters. And then same thing. Yep. Okay, now it wants us to draft these stiffeners, but I don't want to do it for each one of them. So I'm going to go back to before we did our rectilinear pattern. Do our drafts of 5 degrees on this side and this side, with our neutral element being this face. Let's see if it does it correctly. Yep, that should be right. It just refers the direction, and I previewed it again until it looked like it was the right way, and fill it 2 millimeters around the edge. And it wants us to do a tritangent fillet, so we go to here, and then we go on the drop down and click tritangent, and this is where we create two, or select 2 of the support faces, and then the third face is where it says face to remove. It will delete that face and then create a tangent surface that connects the 2 faces to fillet. So once I connect that and click preview, and you can see that it just creates, it removes that face and replaces it with a tangent face. And then I could do more of the edge tangents around it. And there you go. And once I go back to the pattern, I will have to include the draft and the fillet and the edge fillet. So preview, hopefully it doesn't break. Yep, that seems to work. And do it for this side as well. I'm holding down Control, selecting the draft, tangent fillet, and the edge fillet. Preview seems to work. Okay, cool. Draft the walls. Okay, so it's the same thing for the other ones. It's pretty repetitive, so I'll just move on. The number of holes, a number of holes need to be created, however they need to be. Okay, we need to have some holes, but we want to have it be before the shell feature. So I'll go back here and I'm actually going to create a new geometrical set. That's not what I wanted. And I'm going to reorder children, bring that up there. Okay. I'm going to name this the whole locations. So it wants us to do 3 reference points with these coordinates. Sure. -210, -84. And remember that this could also just be defined in the sketch as well. 35, 135, -35. I hid some of the other points just so it seems like, okay, just so I could see these 3 whole locations. And for some reason, it doesn't want to create anything. Counterpole. Right, the whole locations don't seem to want to work, so I'm going to create a multi-hole feature here and just create a sketch within here. Um, reverse H swap. Part origin. Okay, I'm gonna make a point over here. Coincident. Another point. Make it coincident, and that should be good. Sketch 24. Make it counterboard. Don't know what's doing this. So stupid. There you go. Okay, counterbore. His counterbore is 15. Counterboard depth should be 5. The actual depth should be 20. There you go. Okay, so we have the counterbore. I flip the direction. The main diameter should be 10, main depth 20, and here as follows. Okay. And it wants countersunk holes. Same procedure. You could do it for multiple. I'll just do it for this one right here. So again, I'm going to create a sketch. Um, sketch on that face. Yep, that's right. And I'll project this, say, okay, exit the sketch. I should be able to come back here and create a countersunk hole. I'm not too focused on the dimensions. And there you have it. Now we could go back and make the whole thing work. And it should have shelled out the holes on the other side, which it seems like it did. Okay. I mean, the only thing different that you should have done for this, for example, is when you went to the multi-hole. Just just up to next preview should create a hole. Once you go back, it should now be a through hole. There you go. That's how you make those. And it wants you to draft it and whatnot, but it's the same procedures as before. Um, I think so. This is the same thing. You create the stiffeners and do okay, this is like the same thing. You do a stiffener and you create a circular pattern instead of a rectilinear one that we did for the side stiffeners. So that would be a little repetitive. Something new that I do want to try out is this groove over here. So let's do that. So it's just going to be on this base plane. So make sure we're in the right place. Yep. And let's do the following sketch. I'm going to use the profile thing again, the profile tool, but I'm going to click and drag until I get a fillet. And once I get here, I'm going to click and drag, and now I'll get a fillet again. I shouldn't have click and drag on that one. I'll click escape. We'll continue on, click and drag, and just click, and then click and drag again. Now I could just make all of these the same. Let's say this, make them equal. Okay, there you go. And E15 from the edges. And should be 55 side to side. I don't know why I didn't keep the tangent. Doesn't seem to keep its tangency, but we'll see. Okay. 15. There you go. It's now ISO constrained, so we're good to go. They use sketch fillets, but it would be the same thing. Let's see. I can't really tell what kind of profile they're using, so I'll make my own. And then I'll make a reference point on the sketch and create a plane normal to it. I could click this curve right here. Okay. And I could sketch on here. And I'll make just some random profile. I'll call it, say, 5. And then we'll do a sweep. Or in this case, it's called a rib profile with the center curve over here. Cancel, because I actually want to do a groove, not a rib, just a negative version of it. Profile here. Oh wait, sorry. My mistake. Model slot. That's what I'm looking for. Center curve here. Okay, cool. Now created basically what we're looking for. And then we add fillets on that, and we could do a flange now. Okay, now we could do a positioned sketch on the XY plane. Should be basically this plane right here. We'll do the projection of the face. Near element will be, let's see, that plane over there. Now we could use this as the path for the flange. Now I would like to point out that uh, for some sketches, especially the sketches that don't get absorbed, it would be nice to put them separately in a geometrical set. But for right now, I'm just gonna chug them out in order. I'll rename this as the flange path. And I don't really need to, I'll just do a very basic profile. I'll sketch on here. I'll somewhat follow the sketch. I'm just going to just do a simple profile. Should be good enough for our purposes. Trim this side so it's a closed profile. The circles aren't really concentric, but this is just for show. And then I could do a rib. Here's my profile. Here's my curve. And okay. It did give us a warning, most likely because my initial profile wasn't the best. But you can see how it did create that flange. Yeah, and besides some more repetitive billets and drafting, that's basically the idea of it. You can see it on the bottom here. We have our stiffeners. It looks pretty good. Later, I'll go more over some better organization practices, but this was a good introduction into. But this was probably a good part or practice for the consolidation of all of the features so far. All right, thank you.